The time equation of motion of an object is x equal 4t squared plus 10t plus 2 in SI units. What is the nature of motion? Justify your answer. The motion is uniformly accelerated rectilinear motion because the position time equation is in the form of x equal half at squared plus v naught t plus x naught, and a is positive. It's not enough to mention this one because this is true also for UDRM. So here you have to mention also that a is positive. That's why it's accelerated. If it was negative, then it would be decelerated. Calculate the values v naught, x naught, and a by comparing x equal 4t squared plus 10t plus 2 to x equal half at squared plus v naught t plus x naught. We have that half a equals 4, so a over 2 equals 4, then a equals 4 times 2 equals 8 meter per second squared. So please make sure that you do not consider the coefficient of t squared to be equal to 8, it's equal to half a. V naught, which is the coefficient of t, is equal to 10, and x naught, which is the constant standing alone without being multiplied by t, is 2 meters. Write the expression of speed as a function of time. Now you have the general equation of the speed for UARM is v equal at plus v naught. Having a and having v naught, you can substitute in it. So a is equal to 8 and v naught is 10, and you have to mention that t is in seconds and v in meter per second. Now find the position and speed of the object at t equals 1 second. So t equal 1 second, you do the substitutions, okay, in the time equation, the position time equation and the speed time equation. 4 into 1 squared plus 10 times 1 plus 2 is equal to 60 meter, and for the v it's equal to 8 times 1 plus 10 equal 80 meter per second. Now drawing x versus t and v versus t and a versus t curves. Okay, we know that it's a parabola for UARM, so we have to consider some particular points. At t equals 0 is already given, which is the initial position. So as you can see here, I considered a scale in which 1 centimeter on the paper represents 2 meter and 1 centimeter represents 0.2 seconds on the time axis. So 0t, this is the first point. The second point I considered is 116, so the one obtained here. Now when I checked it out, I felt that I cannot easily draw it from 2 to 16. It's going to be a straight line, so I need some point in between these two values or these 2 points. So I chose another point that belongs to this interval, which is 0, 1. I chose 0.5. So if you do the substitution and the time equation, position time equation, you have that 4 times 0.5 squared plus 10 times 0.5 plus 2, you are going to obtain 8. So you draw it and then you join the 3 points in the form of a parabola. Now, similarly for the representation of the speed versus t, you have to do the substitutions in the speed time equation. So you substitute in v equal 8t plus 10, and for 0 it's obtained 10, for 1 it's already obtained 18. Now you have to find for t equal 2, it's equal, the v is going to be 26 because you have 8 times 2 is here you have 8 times 2 is 16 plus 10 is 26. So considering a scale, every 1 centimeter on the y-axis is 10 meter per second, and on the x-axis I considered 3 centimeter equal 1 second. Locating the 3 points, then joining them, we already know that for UARM, the graph is going to be an increasing straight line as obtained. And finally, for the a, it's constant equal 8 meter per second squared, so I considered every 1 centimeter equal 1 meter per second squared, and no need to consider a time a scale for the time axis because it's constant with respect to time, so whatever scale you consider, it's going to be correct.